Okay, Algebra 2, Unit 6, Lesson 14 is called Transforming Trigonometric Functions, particularly transforming trig functions horizontally. We've already done some vertical translations with changing the amplitude, which is basically a vertical stretch. And we've done some vertical translations, which is basically a vertical shift when we move the midline. So we're going to do a little bit with translating horizontally. So our learning goal is I can graph horizontal translations of trigonometric functions, and I can use the amplitude and midline of a trigonometric equation to describe a situation. All right, so our warm-up, take something that we've already done. We've already graphed parabolas, and we've already translated parabolas horizontally. So what they want you to do is match each equation with the right graph. Hopefully you remember enough about your transformations and particularly horizontal translations, and you can do it. This first one here is y equals x squared. That's our parent function. If I have the second equation, y equals x minus 1 squared, you should kind of remember that's going to take this parent function, y equals x squared, and when I have that minus 1, that's going to shift it right 1, just like that. So that is going to give me graph C over here. So there's that. And then the x plus 3, changing the x to x plus 3 is going to translate it left 3, just like that. So that gives me graph B. Okay. So that might make you remember your transformation rules. If you start with f of x, and then you go to f of x minus a, that is going to be a horizontal translation of a units. Okay, so it's particularly important to notice that the formula has a minus a. So when you add that extra negative sign, it ends up being the opposite of what it looks like. So, when I look at this one over here, when I look at this x minus 1, your initial thought is, oh, minus 1. Negative numbers go to the left, and your initial thought is probably it's going to translate left 1, but that's not the way the horizontal translations work. They're always the opposite of what it looks like. It's going to go to the right 1. Okay, and same thing here with this. Oh wait, I wrote that wrong. That was x plus 3. Sorry. The x plus 3 is going to move to the left 3. So it's opposite of what it looks like. Okay, so there you go. Now what I'm going to do is just to refresh your memory about how translations work, I'm going to just go to Desmos, and I'm going to put some parent functions up here, and I'm going to translate them horizontally. So I'm going to start out with this equation, y equals x cubed, and I'm just going to replace the x with x plus 2, and I'm going to see that it clearly moves left 2. But, oh, you know what? I need to change my axes. I'm going to make them go negative 10, 10, and go by 1. There you go. You can see a little bit better there. Goes left 2. And if I did y equals x minus 5 cubed, that's going to move to the right 5. Okay, so it works with any graph no matter what the shape is. So what I'm going to do now is I want you to think about this graph. We'll start with y equals cosine of x, and I want you to think, you should know what that graph looks like. I want you to take a minute, think about what that graph looks like, and I want you to think what this graph will look like. Okay. So we should know that y equals cosine of x is going to pi over 2, pi, 3 pi over 2, and 2 pi. We know the period length is 2 pi. It's going to start at 1 because it's a cosine graph, go to 0, and we can get these values from the unit circle. Okay, so you should know enough to realize, oh, this means it's going to translate left pi over 2 units. So basically what would happen is, if this was negative pi over 2, the entire graph is going to slide left pi over 2, just like that. Okay, everything moved to the left pi over 2 units. All right, every point moved left pi over 2 units. Okay, so on this one was, all right, so you kind of got a good idea of what's going to happen there. So now what I'm going to do is I'm going to go over to Desmos and I'm going to graph some functions here, and we're going to play around with it a little bit. So I'm going to change my axes. I'm going to go negative 4 pi to 4 pi, and I'm going to go by pi over 2. And I'm going to start out with y equals sine of x. So sine of x, the difference is it starts at 0, it doesn't start at 1. And let's do some translation. So y equals sine of x minus pi over 2. So what happens, it moves left pi over 2. You can see there, I'm sorry, it moves right pi over 2. I'm going from the purple to the black graph. I translate horizontally to the right pi over 2. You can kind of see right there, every point, pick a point like right there, that moves to the right pi over 2. Right here, that moves to the right pi over 2. And you can kind of see here, in between them, that's pi over 2. Let's do a different one here. What if I said y plus pi over 6? Well, it's going to go right pi over 6 units. So, I'm sorry, left pi over 6 units. Keep looking at the wrong graph. So it goes from the purple graph to the black graph, and you can see that it moves left pi over 6 when I change my function from y equals sine of x to y equals sine of x plus pi over 6. Right, you can kind of play around with that. If you want to pause the video and open up Desmos and play around with some different functions, you could. What I really want you to look at here is this one now. What if I did minus pi, sorry, let's make it plus pi over 2. So we're going from the purple graph to the black graph. What you should notice there is when I translate that sine of x function left pi over 2, it looks just like a cosine function. So what I'm going to do here is I'm going to type in y equals cosine of x. And what you notice is it's the same as y equals sine of x plus pi over 2. You should notice that these two right here are the same graph. They're right on top of each other. Okay, see that? So that's kind of cool. And obviously they look like the same shape, so you could kind of figure out that you can move them around and translate them to get them to equal each other. All right, so now that we're familiar with this a little bit, let's take a look at this question here. So here are 3 equations for 3 different windmills. Each equation describes the height h in feet above the ground of a point at the tip of a blade of a different windmill. The point is at the far right when the angle theta takes the value of 0. Describe each windmill and how it's spinning. Okay, so what we learned in the last unit in 6.13 was that this moves my graph up 10 units, and this value here makes the amplitude 2.5 instead of 1. So what's going to happen is your graph is going to, if this is my sine graph here, okay, everything's going to shift up, and then it's also going to get wider, or get a bigger amplitude. So it's going to change the amplitude and then shift up. The midline is going to be up here at 10, somewhere around there, okay? So if I want to describe it, I think the best way to do it is to just kind of make a table here. So instead of x and y, I'm going to use theta and h because that's what they have. So I'm just going to say, okay, at 0, normally if I were to plug in 0 to this function, we say, okay, what's the sine of 0? And without a calculator, you should know it from the unit circle, it's 0. So 2.5 times 0 plus 10 is just going to be that 0, so it's going to be 10. You can think about it, it's starting 10 feet above the ground. So this is my middle here. This is 0. This would be pi over 2. This would be pi. So what I'm going to do to describe it here, I'm going to just make a table. I'm going to do a full rotation. So I'm back to the same height at pi, and I'm back to the same height at 2 pi, because my windmill, obviously at pi, I'm right there, same height, and back at 2 pi, which would be right here, back at the same spot. So those are all 10. So we could say, if I wanted to describe it, these are the middle. Now, up here at the top, I'm going to add another 2.5 onto the 10. So that would be 12.5. Down here at the bottom, I'm going to subtract 2.5. So that's going to be at 7.5. And so this would be the bottom. This would be at the top. Okay? So I go on, I do the next one. Kind of make a similar table here. So we got theta and h, 0, pi over 2, pi, 3 pi over 2, 2 pi. And kind of the same situation here. We're just shifting up 3 now. So it's 0, pi, and 2 pi, we're at 3. My amplitude's 4/5, so at pi over 2, we're going to be up at the top. So that's going to be 3 4/5. And at 3 pi over 2, we're at the bottom, so that's going to be 2 1/5. Okay, so same idea here. This is the middle, middle, middle. This is at the bottom, and this is at the top. Now the next one's a little different because you got that negative sign there. So it's going to flip the top and bottom. So when I go to make my table here describing this, all right, we're 5 feet above because of the midline moving up, so everything moves up 5. And then at pi over 2, it's actually going to be, this is going to be the bottom here. So that's going to be 3.5, and this is going to be 6.5. Now, if you're a little confused, you could just do this. Negative 1.5 times the sine of pi over 2 plus 5. So the sine of pi over 2, you should know this is equal to 1. So it's negative 1.5 times 1. So that gives you 3.5. That's how I get that value. And then everything's the same. With the 3 pi over 2, it would just be -1, so then you'd add it. And there you go. So this would actually, since this is the highest value, that would be the top. This would be the bottom, and these would be in the middle. Okay, so didn't do any horizontal translations yet. We're really just kind of taking what we did yesterday, applying it to a situation, with raising the amplitude and changing the midline a little bit. All right. All right, on to the next one. So a fan has a radius of 1 foot. A point P starts in the position shown in the picture. The center of the fan is at 0, 0. And the point P is at the position, at the pi over 6 position on the circle. Fan turns counterclockwise direction. Sketch a graph of the horizontal position in feet of P as a function of the angle rotation theta of the fan from its starting position. So this is a little different than the last one. First of all, it talks about the horizontal position. So on the unit circle, you should know that a point is cosine theta, sine theta. So the last one we were talking vertical position, so we were looking at the y coordinate. Horizontal position is the x coordinate on the unit circle. So we're going to be looking at the cosine of the angle. So that's the first difference. If you look at the last problem, they all had sine because we're talking about the vertical, we're talking about the height. It's a little confusing. They use h. I think of horizontal when I look at h, but we're talking about the vertical height, so they use sine. So on this one, horizontal, we're going to use cosine. Because the radius is 1, we don't have an amplitude change. And because it's centered at 0, 0, we don't have our midline moving up. So it's just going to be y equals cosine. And then here's the thing. If this is my center, I'm starting out pi over 6 radians ahead. It's kind of like my angle is theta plus pi over 6 because we're starting out pi over 6 radians in front of the 0 position. It's kind of like you take your theta and you add pi over 6 to it. Okay? So that's like because you're starting ahead. Now, how does that graph compare to the graph of h equals cosine theta? I don't really like how that h is. So h equals cosine theta. Well, you can kind of tell. Oh, you know what? I should have used h instead of that. So you can obviously tell from what we did in the warm-up and beforehand, we can tell that it's a horizontal translation. Left pi over 6 units. Okay, so if I wanted to graph it, what I'm going to do is I'm going to just sketch cosine theta, and I'm just going to move everything to the left pi over 6. So you should know the cosine theta graph. You know what? Move this down a little. Starts up here at 1, 0, -1. Should look like this. And you know what? I should change this to theta and h instead of x and y. I keep wanting to do y. Okay, h for horizontal. And everything's going to move to the left pi over 6. So each one of these marks is actually pi over 6 because, if you think about a 90-degree angle, this is pi over 2, this is 0, this is pi over 6, this is 2 pi over 6, which is really pi over 3, and then we have pi over 2. So it's kind of like I cut it into thirds. So if I were to just move this thing, click on it, left pi over 6, that would be my graph right there. Okay, so this moves to the left pi over 6, so that's really here at negative pi over 6. This is here at 2 pi over 6, which is pi over 3. This is right here at 5 pi over 6. This is going to be, what would that be? 4 pi over 3. It's really 8 pi over 6. And then this point here is 11 pi over 6. So that's probably the easiest way to do it. Just sketch the original graph and then move everything left pi over 6. If you're not sure about the coordinates, you could always take the x coordinates and subtract pi over 6 from your table if you wanted to. All right, on to the next one. Sketch the graph of the vertical position, v in feet of p, as a function of the angle of rotation theta. So everything's the same here. It's just going to be a sine function. So I have to use v instead of h. So I'm going to change my axis to v. No, I'm sorry, this is v. Sorry, and then this is theta. Okay. V equals sine of theta plus pi over 6, because we're still starting out ahead. So there's my function. Change this, that v down there. Same translation, it's just a different starting graph. All right, so probably going to start by graphing the sine graph. Move everything left. Pi over 6. Now my graph is a little off here. You can kind of see. Should be dipping down there. So there it is. All right, so here's my function. How does the 2 from the equation show up on the graph? Well, obviously that 2 in front means that the amplitude is 2. And again, amplitude is from midline to your max, or midline to your min. All right, that's your amplitude. Abbreviate it. What does a -1 do? Well, that's going to shift my graph down 1. So my midline is y equals -1. And then those are both from the last lesson. That was from 6.13, 6.14 today. How does the negative pi over 4? That's going to be a horizontal translation, right pi over 4. Okay, so you can kind of see from the graph there what's happening. So, you might look and be like, oh, well, it doesn't look like it went to the right pi over 4 because pi over 4 is right there. Remember, everything moved down, so your midline is down here at -1, so you can see that your sine curve definitely shifted down and right. So your original would have been somewhere like this. I moved down 1 and then right pi over 4 looks good. And my amplitude is is obviously bigger as well. Okay. All right, last two things. Cool down. So here's my function h. Describes the height h in feet above the ground of a point on the end of a blade, the wind turbine, as a function of the angle of rotation theta of the blade. The point starts directly to the right of the center windmill. Describe the windmill and how it is spinning. Okay, so I'm going to just maybe make a table here. So I'm going to go theta and h. So we're going to start here. So we start, it's 260 above. At pi over 2, it would be, so the sine of pi over 2 is 1. 1 times negative 150 is negative 150, plus 260 would be 110. Pi would still be at 260. Just plugging these in and finding the sine of each one. This is going to be, so the sine of 3 pi over 2 is negative 1. And then negative 150 times negative 1 is 150. So that would be 410 right here. And then back to 2 pi, we're back to 260. So you can kind of tell here, okay, this is the middle. And this would be up at the top, and this would be at the bottom. Okay. So how would the equation for the blade of the wind turbine change if the point starts at the pi over 2 position? So it starts there. So it's like you're getting a head start. So you have to add it to your angle. So it's going to be sine of theta plus pi over 2. So not going to graph it or make a table or anything. It doesn't ask me to. We know that it's going to, on a graph, it's going to be a horizontal translation left pi over 2 units from the previous function. All right. Okay, so that's it for the lesson today.